Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the different types of DC motor. So previously we have discussed about the torque equation of DC motor and different types of the DC generator. Now in today's video lecture, we are going to discuss about the different types of DC motor. So here, we have to discuss the different types of DC motor here. So in that, the types of DC motor. So here, the types of DC motor which are classified into two types. So first one is the self-excited DC motor and second one is separately excited DC motor. Okay. So here again the self-excited DC motor is classified into three types. The self-excited DC motor is classified into three types. So in that, the first one is series wound DC motor. Here is the first one, and second one is shunt wound DC motor, and third one is compound wound DC motor. Again, the compound wound DC motor is classified into two types. That is short shunt compound wound DC motor and another one is long shunt compound wound DC motor. Okay. So these three belongs to self-excited DC motor. Now in today's video session, we are going to discuss about the series and shunt wound DC motor. Okay. So here, in the self-excited DC motor, so we are having the first one is series wound DC motor. So for the series wound DC motor, so we are having the armature and field windings are connected in series across one voltage source, right? So here for the DC motor, the conversion of DC motor is which converts electrical energy into mechanical energy. Okay. So here, first draw the circuit here. So we are having the DC motor and this is the symbol of motor or symbol of the generator. So we are talking about the motor. So here I am taking the motor here. So motor in series with armature resistance and in series with field winding are connected to DC supply. So here is connected to the DC supply. So here plus minus supply voltage is V, and for the armature resistance, so for the armature we are having the armature resistance, that is RA, and for the series field winding we are having the resistance as RSC, series field resistance. Okay. And here for the motor side we are having the output power, or we are having the generated EMF, that I am taking as EB. So EB is nothing but back EMF. Okay. So now for this series circuit we need to give the current directions first. So supply is here. Now give the current directions. From the source we are having the current, that current I am taking as I. So we are having the supply voltage. From the supply we are having the current is I and current through RSC. So current is flowing through the RSC RA. So current through this RSC I am taking as ISC. ISC means series field current, and current through RA, current through armature resistance, that I am taking as IA, is armature current. Okay. So now for this series wound DC motor, now we need to write the current relation, voltage relation and power relations of the given series wound DC motor. So first write the current relations here. So here it is a series circuit. In this series circuit, current is constant. So therefore the total current is I equal to ISC, that is equal to IA. So current is constant, that's why I equal to series field current is equal to armature current. So all the currents are same through the RSC and RA. And similarly, now we have to write the voltage relations. So the voltage relations of the series wound DC motor is, so in this case, so we have to apply KVL in this loop. So apply KVL in this loop. So here I am starting from this point. When we are applying the KVL, always we need to take the second polarity. So here the second polarity is plus and voltage is V. So plus V minus voltage drop across RSC is ISC into RSC. So ISC into RSC, and voltage drop across RA minus IA RA, and voltage drop across this motor EB, that is equal to 0, or the motor developed by the EMF EB, that is equal to 0. Now by using this equation, we have to calculate the back EMF of DC motor. So then EB equal to, so here EB equal to V minus IA RA minus ISC RSC. And for this motor, we are having the brush voltage drop, that is minus VB. So in this equation, this IA and ISC both are same only. So then EB equal to V minus, I am taking IA as a common term here. So IA into RA plus RSC minus brush voltage drop is VB. Right, here is the voltage relation of series wound DC motor. Similarly, power. So power from the source. So power from the source is, that is I am taking as PS. Power from the source is equal to, so V into I or V into ISC or V into IA, because it is a series connection. In series connection, current is constant. So that's why PS is equal to V into I or V into ISC or V into IA. Similarly, power, the mechanical power developed by the DC motor. The mechanical power developed by the DC motor is given as EB into IA or EB into ISC or EB into I. These are the power relations of series wound DC motor. Okay, so this is the current relation of the DC motor, and this is the voltage relation of the DC motor, and these two are power relations of the DC motor. Okay, so this is about the series wound DC motor current, voltage and power relations. Now we will discuss about the second type, that is shunt wound DC motor. So here in this shunt wound DC motor, so shunt is nothing but it is a parallel connection. So first we have to draw the circuit here. So here is the DC motor in series with armature resistance. So it is connected with shunt field winding, and this side we need to give the DC supply. So plus minus supply voltage is V, and this is motor. For this motor we are having the back EMF EB, and this is armature resistance RA, and this is shunt field resistance having the shunt for the shunt field winding having the shunt field resistance, that is RSH. Right, now for this shunt wound DC motor, now we need to give the current directions first. So here supply is there, Now from this supply, the electrical current is passing through the RA and RSH. Now here current is I. If you are giving the DC supply, the electrical current is passes through the armature resistance and shunt field resistance, right? So I is there. This I towards this point. The total current is towards this point. From this point, current is dividing. The total current is dividing like this. Now current through RA is IA. Current through RSH is ISH. So IA means armature current, ISH is shunt field current. Okay. So now for this shunt wound DC motor, we need to write the current, voltage and power relations. So first of all, we need to write the current relations first. So what about the current relations? For that, at this node point, apply KCL. So KCL states that the algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. So at this node point, the incoming current is I equal to, so algebraic sum of the outgoing currents, that is IA plus ISH. Okay. So here incoming current is equal to the algebraic sum of the outgoing currents, that is ISH plus IA. Now find out this ISH. So in that case, this is the parallel connection. In parallel connection, voltage is constant. Then ISH is equal to V divided by RSH. Shunt field current ISH is equal to V divided by RSH, that is the ISH value, and the total current I equal to IA plus ISH. So these two are the current relations of shunt wound DC motor. Now voltage relation. Now we have to write the voltage relation of the shunt wound DC motor. So in that case, we have to apply the KVL in this single loop. So we have to apply KVL in this loop or apply KVL in this loop. So source is this side. So I am applying KVL in this loop. Okay. So I am starting from here. I am starting from this point. So when I am starting from this point, always we need to take the second polarity. So second polarity is plus V. Plus V minus. So voltage drop across this RA is IA RA, and voltage drop across this motor minus EB is equal to 0. So now the back EMF. So we have to find out this back EMF EB. So where EB equal to V minus IA RA minus VB. So VB is nothing but brush voltage drop of the given shunt wound DC motor. So EB equal to V minus IA RA minus VB. Right. So here is the voltage relation of shunt wound DC motor. And third one is power relation. So the power relation of shunt wound DC motor is, so here the power from the source, that is PS, equal to power from the source PS is equal to V into I, where I is nothing but IA plus ISH. Similarly, the mechanical power developed by the motor, the mechanical power developed by this motor is EB into IA. So that is equal to EB into IA. Right. Here is the current relations of shunt wound DC motor, and this is the voltage relation of the shunt wound DC motor, and this is the power relation of the shunt wound DC motor. Okay. Here is the two types of series and shunt wound DC motor. Okay. So now we'll discuss the problems on the types of DC motor. Okay, so here so we are having the problem. So a 250 volt DC shunt motor takes 41 ampere at full load resistance of motor armature and shunt field winding are 0.1 ohm and 250 ohm respectively. So find the back EMF on full load. So we have to find out the EB value here. EB value of DC shunt motor. So here first of all we need to draw the circuit here. So here is the shunt type DC motor. So this is the DC supply, plus minus V, and this is motor. So here we have to find out the EB value, and this is armature resistance RA, and this is shunt field resistance RSH. Now give the current directions. So total current is I. From this point current is dividing. So current through RA is IA, current through RSH is ISH. Okay, so here is the circuit, it belongs to shunt wound DC motor, right? So now by using the given data we have to calculate the back EMF, that is EB. So here a 250 volt DC motor, so means the total voltage is given, supply voltage V equal to 250 volts. So first we have to write the given data. So V equal to 250 volts and 41 ampere at full load. So total current also is given, that is I equal to 41 amperes. So full load resistance of motor, if it is a armature and shunt field windings are 0.1. So it is a armature resistance RA equal to 0.1 ohm and shunt field winding RSH equal to 250 ohm. So armature resistance is 0.1 ohm and shunt field resistance is 250 ohm respectively. Now we have to calculate the back EMF EB. So where EB equal to, the equation is V minus IA RA. So here the total supply voltage is there 250 volts, armature resistance also is there 0.1 ohm. Now we have to find out this IA. So from this shunt wound DC motor, total current is equal to, so apply KCL here. So incoming current is equal to the algebraic sum of the outgoing currents, that is I equal to IA plus ISH. So here we have to calculate this armature current IA, where IA equal to I minus ISH. So already we are having the total current, that is 41 ampere. Now we have to find out the ISH value. So the formula of ISH is V divided by RSH, that is equal to, so the total voltage is 250 volts divided by shunt field resistance RSH is 250 ohms. So these two get cancelled, we will get 1 amperes. Now substitute shunt field current and total current in this equation. We will get armature current IA. So IA equal to I minus ISH. I is 41 minus ISH is 1, that equal to 40 amperes. This is the armature current. Okay. So now we have to find out the EB. that is back EMF EB equal to V minus IARA. So now EB equal to V minus IA into RA, that equal to what is V? Supply voltage 250 minus IA 40 into RA 0.1. So 250 minus 40 into 0.1. So by solving this equation, we'll get 246 volts. This is the back EMF of given shunt wound DC motor. Okay, so EB equal to 246 volts. So in this problem, so first we have to write the given data. After that, we have to find out the EB value. So EB equal to the formula of EB is V minus IARA, and already we know from the shunt wound DC motor, the total current is equal to the IA plus ISH. By using this equation, we'll get armature current IA. Now substitute all the values in this equation, we'll get EB value, that is 246 volts. Okay, here is the one problem, and we'll go for the next problem. So in this second problem, the armature of a DC machine, has a resistance of 0.1 ohm and is connected to a 230 volt supply. So calculate the back EMF when it is running as a generator. So first bit is, when it is running as a generator, the current is 80 amperes, and if it is running as a motor, the current also 80 amperes. So here we have to calculate the EB. If it is a generator, what is the generated EMF? If it is a motor, what is the back EMF? Okay, so in this equation, in this problem, first we have to write the given data. So here the given data is, the armature of a DC machine has a resistance of 0.1 ohm, means armature resistance is given RA equal to 0.1 ohm, and voltage V equal to 230 volts. So supply voltage for the motor, or terminal voltage for the generator. So V equal to 230 volt. Then we have to calculate the EB value. Right. So here the first bit, if it is a generator, the current is given, that is armature current is given, IA equal to 80 amperes. Now we need to calculate the generated voltage, that is EG equal to V plus IA RA is the equation. Okay, basically this problem belongs to shunt type DC generator. So EG, for the shunt wound DC generator, the equation is EG equal to V plus IA RA. Then that is equal to V 230 plus armature current is 80 and armature resistance is 0.1. Now by solving this equation, 230 plus 80 into 0.1 will get 238 volts is the generated voltage of the given DC shunt generator. Right, here is the first bit. Now the second bit is, if it is a motor, the current, armature current IA equal to 80 amperes. Now we have to calculate the back EMF. So here EB equal to V minus IA into RA, that equal to, what is V here? 230 minus IA 80 into armature resistance is 0.1. Now by solving this equation, we'll get 222 volts is the back EMF of given shunt wound DC motor. Okay, so these are the generated voltage of the DC generator, and this is the back EMF of the DC motor. Okay, so these are the two problems on the shunt type DC generator. So in next class, we'll discuss about the compound wound DC motor. Okay, so thank you one and all.